Swayam Prabha. Digital India. Educated India.
In this lecture, what we have seen is that in the previous lecture we know how to calculate the total the ultimate bearing capacity, then difference settlement, and also we will now see total settlement. Actually, these settlement calculations, bearing capacity improvement calculations are very important, and we need to compare them with actual results also. For example, the design issues in many of these mixes are very important, and for which we need to understand some mechanics part of it, like say for example the total settlements. How do you calculate in the case of lime treated soils? Actually, these methods are applicable to all types of materials, soil materials which are treated with like say for example, instead of lime columns you may have stone columns or anything. There are people have developed at various times some design methods, and if you look at the literature, there could be different design methods, but one should understand that all these methods are based on different theories and also a lot of practical experience, and the results from each method could be totally different. But what normal practice is that people calculate all the values, like ultimate bearing capacity, then settlements, then all that, then predict with what is observed. We will see that, and the total settlement predictions are very important. And how do you do that is that like you have a simple theory which is based on load distribution. This is again an approximate elastic solution theory, in which like the settlements is composed of two components that we will see. Why this settlement calculations required are essentially is that, say for example, the water supply lines and sewer lines have a tendency, like they can't tolerate difference and settle total settlements. If the settlements are going to be higher in materials, then they crack and all that, break up. So here you can see a simple diagram in which this is the loaded area, this is all the loaded area. You would like to calculate the settlements. What you assume is that the settlement is assumed to be equal to the sum of the compression of the reinforced block. Actually, this is the reinforced block, like see, the thing is, this is all a strong area compared to the rest of the area, and we assume that there is a settlement of delta H1 here, right, in the area, and then it gets, now there is nothing that exists here. Like most of the times there will be always a question that should I take it to the hard stratum, like should I say if the hard stratum is 20 meters, should I take the length of the pile to 20 meters? Actually, in most of the stone columns we will have this, or even piles we have this question, but it is not necessary. We have to calculate, actually we know the depth of pressure bulb concept, that beyond certain area loads may not come. So if the loads are not coming here, then there is no point. So at least you need to you do not need to extend the columns to the bottommost level. That is what the point is. So what we want to do is that you have to calculate this reinforced block delta H1 settlement, and also the compression of the underlying soil. Because of this load, applied load, it has two components, delta H1 and delta H2, and you are trying to calculate that. So you can see that the load here is about the load that is applied, and then a load applied on each of these it is B is the area and L is that whatever. Say for example, assume that it is a tank foundation or some rectangular foundation, you have to put that B into L properly, and it can be even a 1 meter length in the case of a pavement, the highway embankment. You can just take it as 1 meter and then do that or whatever, right. So here the applied, this is a Q1 load that is applied onto this block, and then we assume that the Q1 also acts here, and now the load acting here is Q2 is nothing but the Q minus Q1, whatever is that load, and then how do you get this, say this is Q2 here, Q2, and then what is that, it gets distributed here. Okay. So, that distributed load is in terms of the, again as I said, B plus H into L plus H, it is like we assume that it is 1:2 rule is followed. So, it is like you add on both sides, this becomes instead of B into L, this becomes B plus H into L into H. So, here the, okay, fine, this is P. Okay. The compression delta H1 depends on the interaction between the columns and the enclosed unstabilized soil. The measurements indicate that the compression of the columns is the same as the compression in the unstable soil between the columns. So, we normally say that the settlements are, we assume that, because there is a it is a strain compatibility, we call it. Measurements indicate that the compression of the columns is same as that of the unstable soil. What is happening is that load is coming more on the column than the soil, which means that they, the moment the load is applied, they do not have unequal settlements, that is what it means. And there are two cases here when the applied load is very high, such that the plastic limit of the column is reached, like we call it highest load. And the second thing is applied load and the deformation of the block are small, so that the plastic limit is not exceeded. Actually, if the loading is higher or lower, we have some analysis here, some understanding of the analysis. As I just mentioned, we have different ways of doing this, some of these issues. Total settlement, this settlement can be estimated by dividing the applied load into two parts, Q1 and Q2, in which Q1 is a part carried by the columns and Q2 is a part carried by the enclosed soil. Q1 is a column is dependent on the, actually this is a it is not actually the creep limit, it is the limit, like plastic limit of the soil, it is the CUL of the stabilized soil. If you know the bearing capacity, the Cu of the stone column, the lime column, treated lime column, say for example you get some 10 kPa soil I mean say 20 kPa or something, you may get 100 kPa as that treated material here. 100 into 0.7, 70 kPa would be the load. Okay. That is a limit. The settlement D H2 caused by the Q2 can be calculated from the consolidation test and test samples. Actually, as I just mentioned in the previous class, yeah, this is a soil is there, and then this is a the lime column material is there. The lime column material has some settlement, and the stone also the lime in between the two lime columns also, the soil between the two lime columns also is clay. So, what it does is that settlement delta H2 caused by the load can be calculated from the consolidation settlements and other samples. This is another important point that one should see. And case 2 is a relative stress of the columns with respect to the enclosed unstabilized soil will govern the stress distribution. So, what we do is that in the second case, what I just mentioned previous, let me go back. First case, when the load is applied such that the plastic limit of the soil is reached. Second case is the loads are small. So, you are essentially calculating the loads when they are higher in this form, like Q1 and Q2 calculate in this particular expression, and delta 2 you calculate essentially that. What you are essentially seeing is that, yeah, you are essentially calculating the Q1 Q2 loads under these conditions when the load is very high and when when the load is somewhat lesser. So, in this case yeah, Q1 and Q2 is settlement from this material, use this, and Q2 is calculate the settlements because of the soil layer beneath the stone the lime columns. The other way is that if the was said case 2 when the total load is somewhat very less, what we do is that the relative stiffness of the columns with respect to the enclosed unstabilized will govern the stress distribution. The difference is that in the previous case the loads are so high that they are tested they go to plastic limit conditions. Here loads being lower, we try to use a elastic stress distribution type of thing, like the loads are shared, or you have the concept of M coming into picture here. So, the settlement delta H1 of the reinforced block will be governed by the compression modulus of the column material. So, delta H1 we call it, and Q column is the average axial stress in the column into height is the column length, and then M is that factor that we have to calculate, which is nothing but the compression modulus. Compression modulus is, say for example, there is a modulus of the soil is going to be very very high, that it takes all the load, then the load coming on the clay would be much less, and one can safely use the elastic stress theory concepts. So, this is one case here, delta H1 is nothing but the this is nothing but Q is a average axial stress into height divided by M is nothing but the stiffness. Okay. So, what are you getting is that your this it is like the you are essentially calculating this. So, these two have the same whatever units, then you get in terms of the units of H, the delta H1. And results from the plate load tests indicate that the compression modulus for the short term is about 300 of the unconfined compression or the Q of the column. In fact, as I just mentioned, you have maybe a 10 kPa for the native soil, but it may be very high, even 100 times also, like it can be very big numbers. They have done some plate load tests and they show that the compression modulus of the column for short term loading is about 300 Qu col. So, which is quite high. The model they are trying to relate modulus. Modulus, how do you get modulus? You will get from plate load tests. Okay. So, like as I said, you also have in literature, if you want to get E value, E is 10 times Qu or some sort of equations, we have seen that. Say for example, we have some more equations in literature where if you know the strength properties, you can relate it to stiffness, this something like that. So, results due to consolidation, the value decreases with time to approximately half the initial value. QL is the ultimate unit strength of the columns. So, the compression modulus of the enclosed unstable soil can be obtained as this is another one, like this is another simple say in the case of 4 consolidated soils, this is a simple equation that M soil is 250 times Cu. Okay. So, even for normally consolidated soils you can get some expression. What it means is that if you know the you are trying to do a what is that a consolidation test, and you can do a consolidation test and you can from the consolidation test result you can get this modulus, because whatever are the void ratio, the strain you can calculate, because you have initial height of the sample, it has a final height. So, you are trying to you can calculate one M value there, because you can calculate the stress and the strain, right. Stress by strain can be calculated and that gives M, and for the same sample if you do an unconfined vein shear test there itself, say vein shear test for the same consolidated sample, you will have an equation, one can get an equation like that. That is what people have been doing, like even we did in our laboratory some of these experiments where you have a consolidated sample and then you have a you can have from between two pressures, say for example from 100 kPa to 200 kPa there is some sort of compression that is going on, and then that compression that can be converted to shear strain, and the total stress applied, total stress by total strain can give you a modulus, right. say for example 100 to 200, the 100 kPa is total stress divided by the strain that it has undergone. So, for example 10 divided by 100 MPa divided by 0.1 give you some 2000 as a modulus, right. So, 2000 kPa, which means 2 MPa is the modulus. So, that if you really do a test there, you will get some factor like this. So, one should be very careful with this, some of these factors, and this is one important thing. And you can have some sort of similar relationships. Actually, if you just look at Bowles' book and many other standard books, you have a lot of literature on this. So, as I just mentioned, when the soil is under elastic state and whatever, or when the load is not going to be very high, the equal deformation of the soil and columns we are expecting, and loads, the following relationship must be satisfied. It is like Q1 into BL divided by N A column into M column, the area of the column and the stiffness of the column should be equal to Q2 into BL by BL minus N A col and M soil. Essentially we are trying to see that this is the stiffness of the soil, this is the stiffness of the column, M particularly compression modulus values. So, you are trying to balance that essentially, and N is the number of columns, and area of the cross section area. If the area is defined, if you have a term called area ratio, like we are doing this, number of columns, say for example 10 piles you have, and the area of cross section to total area. This is, say, how much of percentage of the area has been replaced with the lime column material. Is it 10% or 15%? One can use that. Okay. So, essentially what you are trying to do is that you are trying to estimate settlements. So actually some expressions we are having here, and the same delta H1 you can have a simple expression in this form, and you also calculate the settlements. Q1 is transferred to the block. Yeah, case 1, they again the total load, that how much is transferred, there are two cases here. Okay, one can, so there are some sort of simple calculations one can make, and actually why these calculations are important is that you should know what you are doing. Is essentially like these are all very simple calculations, I mean based on some simple assumptions, whether like as I just mentioned in the case of stone column, that you have two theories. One is based on elastic theory, the other one is based on somewhat limit equilibrium analysis. So, you have to compare the values of settlements, strength improvement and all that, because soil mechanics is quite the very tricky, in the sense that for the same problem there are different ways of solving it, and one have the elastic theory, one can have limit equilibrium methods of analysis, one can use a finite element analysis. There are different ways. So, essentially one must be very clear about different methods of analysis, and then finally measure it in the field. That is what people should do. So, these are one type of doing that, particularly for columnar inclusions. There are certain quality control measures one should do, like particularly in this lime column arrangements, the lime columns, they flow, I mean how much of lime is coming into the material should be measured, and sometimes there could be a problem of they have it is a chemical material, the continuous flow, the material should be cleanly coming into the particular column, and then it should form, you just put it and then compact it, and then finally it forms a column. So, the distribution of lime in the columns and the water content samples obtained with auger boring must be checked. In fact, you should be able to do some sort of checks in which how is the distribution of lime columns is migration of the lime is there, and is the lime distribution satisfactory, and all that one can see, and one can calculate the distribution of lime or the diffusion of lime based on the water content. Actually what happens, if the water content of the sample is very high in the beginning, and immediately after you start finding out the water contents after the lime column installation, if there is a good reduction in the water content, definitely it means that there is a diffusion of lime next to the lime column. So, even some more methods suggest that you have to check 1 to 3% of the columns for with SPT or even plate load test and all that, and one should even vein testing should be done. Essentially what we are trying to do is that we are trying to have too many assumptions in geotechnical engineering. We would like to see if whatever we assume are trying to are satisfactory, and we have to make some corrections for that. Then check the strength and deformation properties of the stabilized soil in a few columns with few in situ tests. Say for example, once the lime treatment or the for example the lime columns are poured, you may have to do a plate load test, say for example you have seen the IS code on stone columns, they recommend plate load tests. Similar to that, you have to do plate load tests on a single column or a 3 column or some different columns arrangements. One should check whether the strength improvement is there, whether in terms of the load displacement curves of the plate load test you can get, deformation properties also one can get. So, this is a very important quality control check, and this forms a very important contribution here. I would like to highlight you another important simple method on how do you find out some of these things. Actually, as I just mentioned, in ground improvement, we know how we know that you have to improve the ground, and then you have to have varieties of treatment. But finally, you should have a rough idea of how to calculate things, how bearing capacity is improved or strength is improved. So, what I would be discussing would be a method to evaluate again strength and stiffness gain or the increase. The method is simple here, like what I am trying to do is that this is the E log P curve of the in situ soil before treatment, okay, and E naught is the initial void ratio, like so this has some this thing PC already, and once what I do because of the lime addition, what is going to happen is that there is a reduction in water content. Because of the reduction in water content, what happens, the void ratio will decrease, because we have this formula, right, ES is the simple expression relating water content and void ratio. So, the void ratio comes down. So, as per the void ratio, you have an improved P, like earlier it was this much P, PC it was, and then it now you have added load. So, the load has increased from this to this. So, that is what it means. So, the delta P is what is called the equivalent effective pressure increase due to void ratio reduction is delta P is this P dash minus PC. So, this is one thing. So, we know the how this expression is simple, that you know that CC is nothing but the rate, the delta E divided by the delta of the d log P, dE by d log P is the CC. So, use that expression, and then you put it into this convert back the equation, you will get delta P equal to PC into 10 power dE divided by CC minus 1. The CC you have already, you have the E log P curve for the sample, and then CC could be 1, CC is one variable, and your delta E is already known because of the lime treatment. So, you will get what is the equivalent pressure. So, this is important calculation, because this helps us to calculate how much of if you know how much of pre-consolidation pressure is there, extra load is there, you know how to calculate extra, how much of extra strength gain is there. I will show you by an example here. There is a simple method that was given. See the method, the area was treated by lime columns, and we know what is the area ratio is nothing but if you take a square grid pattern like pi d square by 4 or pi d naught square by 4 is the area of a single column, S square is the area of the grid in a square pattern. So, this area ratio, like it could be 0.1, 0.2 and whatever is the number, it is one area ratio. And for example, I am taking an area ratio of the piles delta is 1, say for example I am taking a 0.4 meter as the diameter of the pile and the spacing is 1 meter. So, I will get AP as 0.1256. So, what it means is that you have 1 meter spacing and then stone column diameter is 0.4, the AP is 0.1256. Okay. Then there is a simple, there is an expression for reduction in water content. The thing is, we know that there is a change in water content because of the lime addition. So, if you know that water content change, then it is quite useful. So, there is an expression here, actually this is based on heat of hydration and other things, and in fact it is given in literature, and actually this how is it you get is that reduction water content of the treated soil is nothing but it needs initial water content. In this case, I am just taking it as 80%. Okay, this water content I am taking as initially water content is very high, maybe this water content exists in the Vizag soil or some place in east coast or west coast, and the unit weight of the soil is 18 I have taken, and H is the absorption of value of the water by lime column and depends on the additives used in preparing the unslaked lime aggregates. Actually there is a value, so this H value is something, this is all known, like we know the initial water content, gamma T is the unit weight of the treated soil, and this factor is something that H and some of these factors we should get. H is absorption value of water by the lime column, depends on the additives used, and we take a value of 0.3 here. Then gamma C is the unit weight of the chemical lime. In fact, the lime or the calcium oxide, the unit weight is quite low, maybe 1 to 2 ton per meter cube. Porosity of the lime column after chemical reaction, we assume that the porosity, because of the void ratio increases, right. Void ratio increases if you put the lime, because it becomes more aggregated than the parallel plated. So, EV is another expansion ratio of the lime column, this is another value is taken as 0.75, and SR is the degree of saturation after the lime pile after treatment. Initially we assume 100%, but once you treat the soil with lime, what happens is that the void ratios, it becomes more void, like because of the particle aggregation, and we use a degree of saturation of 80%, and we know the unit weight of water is 10 kN per meter cube. So, we put all these numbers here and you get a water content change as something like 5.5%. So, initial water content is about 80%, because of the addition of lime I got it reduced by by 5.5%, and it is quite good. I mean the thing is, for which like now further I am trying to calculate, say for example the new void ratio. What is the initial void ratio? Initial void ratio is nothing but 2.16, because 2.7 into 0.8, okay, that is 2.16, and now new void ratio I can calculate, and this delta P, how much is that one can calculate, and PC where it is changing, that it is 100, and one can use some term, yeah. So, the delta P is about 76 kPa, which is quite good. I mean the thing is, just by adding lime, and I just made an effect of like about 75 86 75 kPa extra load I have applied, which is something like you can compare with any other thing. The thing is, you have about surcharge methods and other things, and to apply a surcharge of this, you need 4 meters height of surcharge, and its consolidation is only occurring there. But then here you have chemical changes also, soil is improved and all that, and CC numbers I have calculated. And another one that I would like to show you is that the strength of the increased strength of the soil, like initially there is some strength, and I was SU by P dash is another variable, like which is actually established for many clays, and if you see in Bowles book also it is given, like for various types of clays, like if you want to construct an embankment on a soft soil, what is the how much of load you should do. You have what is called SU by P dash equations, which are, say for example SU by P equal to 0.3 or 0.2 or something people say. It is there in literature, and in this case I have taken it as 0.3 actually. So, if I take SE by as P, it is nothing but the ratio of shear strength divided to overburden pressure. It is actually one can get this equation in this thing. Shear strength will be, say for example, 30 kPa and overburden pressure is 100 kPa. If I go to a depth of 5 meters and 5 meters into 20 is 100, and if I measure the strength there, it will be 30 kPa. What it means is that. So, that value if I put, and then the delta P is also known. So, I will get this as shear strength increase. You can see that then I need to get this a treated soil strength is there, and so then what is the strength of the composite ground is another important variable. There is I think you have to substitute some other number. So, you will get some whatever, these are all simple steps, one can have to have the calculations here, and now the next objective is to get the improved strength of the ground. Again we are trying to use a very simple formula which is again based on the area ratio, and I just mentioned a few minutes back that the strength of the lime treated ground could be higher, 10 times higher. Like if it is 20 kPa for lime, it could be 200 times here. So, that same number one can use here, like it is SP here, area ratio. So, there we have got some 0.1256 as area ratio, which is nothing but the ratio of lime piles in the 1 meter square area. So, that is 0.1256 into 200 into 1 minus this thing. So, you will get some good increase. Okay. So, one can estimate even the settlement, pre-consolidated settlement, how much of settlement you have accelerated here, because you removed water, right. So, I mean what is that preempted settlement is, if you take the HC as the thickness of the soft soil, it is about 470 mm here, one can have all these calculations done and it comes. Then there is another addition here. So, what it means is that you have to calculate the drained modulus of the treated soil also, like ES is the drain modulus of untreated soil. Actually it is because untreated soil is quite poor, I say it is about 10 MPa, and all these area ratios are there. N equal to stress distribution ratio, it is a 10 is what some companies say, and then this leads to 21.3 MPa. 10 MPa has become 21.3 MPa. So, what you are trying to do is that there is an increase in strength, so there is an increase in stiffness. So, we have used the simple mechanics of soil mechanics and trying to use the elastic theory as I just mentioned, like you are essentially trying to use the simple theory of getting this, if you know the in situ ELOC curve of this and some assumptions, we make some assumptions, it is possible for us to calculate the strength gain as well as stiffness gain, which can be used in our calculations, right. Now, I would like to describe a few case studies. One is, it is actually a case study in Malaysia. It was constructed in about 2000, and in this case 400 mm diameter lime piles were installed at 1.7 meter center to center spacing to increase the strength and modulus. Okay. Like an example that I just discussed, one can use that method to check this. In fact, see nowadays what is happening is that there are methods that are well established by the companies, like as I just said, for stone columns, the company Keller has one method that is going to be Pribe's method. Okay. And so they find that it is very appropriate for the way that they are doing the things. So, similar to that, the previous method which I just discussed was given by some other company, and some other authors also followed it in this example. So, for example, I will show you the purpose of the lime treatment was very clear here, to increase the passive resistance and reduce deformation. Say the lime piles, what they do is that we increase the passive resistance. Passive resistance is that like you know when see there is a reinforced soil. So, for example, it increases passive resistance, like see the thing is that it reduces the movements of it restrains the movement in a passive way. So, it restrains the movement of the soil in a passive way. So, this is what is called say for example, if you put lime columns, actually what the material they are even the stone columns. That is why we use the concept of cavity expansion theory, where we calculate say for example, Kp is a term that is used instead of the Ka. Ka stands for the active earth pressure coefficient and Kp stands for the passive earth pressure coefficient. So, if you insert that, what is trying to do is that the passive resistance is increased, okay. Like you have some material in the area, you made it very stiff, and then because of that there is a passive resistance increased, and because of that it reduces deformation for the shoring wall for the purpose of basement construction, to improve trafficability for construction machinery at the base of the excavation. In fact, if the soil is so poor and you can't even walk, the thing is that you have to make it little more workable. So, people use the lime treatment, sprinkle lime, to increase the stiffness of the remaining soft layer for a pile raft foundation system that was proposed for a 23-story tower structure. You can imagine that the height of the structure is 23 floors, and you are looking at its improvement of the bearing capacity. So, up to 23 or 40 meters they have got the stratigraphic profiles. 0 to 8 meters is a soft soil, 8 to 13.5 form clay, and you have varieties of materials here, and the depth of investigation is quite good. Like they went to say for example 23 meters is supposed to be the previous case, yeah, it is a 23 stories, and you can see that the depth of investigation was quite large, about 100 meters, which is quite good, because they have to be very sure about the safety and settlement aspects when you are trying to deal with a technique which you want to be, again you want to save on the construction of foundations. You cannot provide piles, right. So, what does this borehole information say? There are some number of boreholes. You can see the water content is 97 and 100%, it is very high, right. Average is now it is a very liquid actually, right. Liquid limit is about 56, natural water content is more than the liquid limit, you can see that. Plastic limit is there, okay, plastic index is okay, silt is there, clay content is there, which means that it is a very tricky material, when you have all the boreholes up to 7 meters they say, you can see that the original shear strength obtained from vane shear test was about 15 kPa for 5 meters. So, you can they have done vane shear testing also. So, they have done the vane shear testing for 15 kPa, and so it increases up to 5 meters is about 15 kPa, then it increases with to about 30 kPa at about 8 meters depth, okay. These are results for the vane shear untreated ground. So, after the 5 weeks after following this lift normal, vane testing was indicated the shear strength of the soil at the quarter point between the lime columns has increased to 27 to 36 kPa. You can see that it is a very good increase, right. So, from 15 kPa it has become almost double. So, this is that area where it is quite comfortable. So, just like as I just said, you are only accounting for we assume that the treatment the effectiveness is because of the what you call the hydration, the removal of water. Then after that there could be long term benefits also, and definitely the construction of lime tile piles is much easier, and it all depends on the it is a small building or whatever, one should be comfortable. People normally in any contractor in the west, you will have all the people ready for it, like you need to have information from stone columns, PVDs, lime columns, whatever, all that methods, even geogrids, everything is there available. Then you have to make sure that yes, the technique works in a given situation, and then try to come out with which is cheaper also, because if it is very expensive, and you should also have a proper performance monitoring, like you must be able to do like this, a test like this. If the test does not allow you to do anything, then it is very difficult, because how are you sure about the quality of the work done is something very very important. And if I cannot give you that the strength improvement will be like this in calculations, and also show you later with CPT or SPT or any other test that the strength improvement has not is achieved, then if the strength, say for example it is 15 kPa, now it is 36 kPa, which is quite good, right. So another case study that I would like to mention, this is actually a power station in near Hubli. About 4 years back, what happened was that there were a lot of floods, and the substation has it's founded on, actually you have an expanse soil everywhere, that's an expanse soil exists there, and then since you want to construct simple structures, you need to have they put remove some soil of expanse layer and then put some sand cushion or a muram cushion they call it, like this is what they do. You can see that this is all expansive soil here, black one, you can see that this is one sand cushion they put, like say for example people say about 50 centimeters or 2 feet or something. Then they start constructing things like this, you have a substation nicely lined up and all that. That is what happened was that 4 years back there were severe floods, and the whole area got inundated, and there was nobody to even, like the whole area, there was a power cut and all that, they shut down everything. But then they left it, and then they found that after all the drying, because of the inundation, what happened, the whole area got swollen, the expanse soil area that is there in this area, you can see that this is also black color, this removed soil, it is an expansive in nature, and you can see that it has resulted in deformations like this, right. It is out of line, you have to, they have to be in line actually, all the electrical things have to be very, they have a lot of tolerances, and if you have an expanse soil, you should the problem with expanse soil is that it heaves and then shrinks, right. So it could the possibility is that it could cause total settlements as well as different settlements, and in this case the problem is that tilt of the tilt like this, the pole should not be tilted away with respect to something. And the thing is that what type of foundation they have, they will not have any foundation, right. They will have a minimum foundation which could be about 1.2 meters or some 2 meters depending on the type of whatever they have, depending on the junctions, loads coming on that. They have lightly loaded structures, the load that comes on this is much lower compared to the swell pressure. In fact, the expansive soil in this area has a lot of swell pressure, it could be about 150 kP and all that. The load that is coming here is so low that definitely you expect during the heaving and shrinkage, this could, you can see that this is out of line actually, though it may not be visible to the naked eye, particularly these are visible, and then they have to shut down all the operations, and then they have to they restored it, but the problem was that it was not satisfactory. So what I did was that I did a total survey. I would like to first wanted to know what is the vertical tilt. The vertical tilt is this, like how much of tilt is there in the pole, vertical tilt, and then the horizontal tilt, like horizontal tilt of the foundations as well as the vertical tilt of the vertical members. So in cases, so when we did with the total station, I was able to see that the differential settlement is about 20 mm in some cases. Say for example, as I just mentioned, it is resting on about 1.2 meters foundation and it got tilted, it is about 20 mm, though number is small, but then this foundation size is also very small. The height of the pole is about 2 meters, like it is electrical poles of 2 to 3 meters average height, and there is a tilt is about 69 mm, you can see it is quite big. And the electrical, as per the electrical transformer, the substation rules, and they have some guidelines on erection of these facilities. The permissible value is about L by 300, which is corresponds to 6.67 mm. So you can see that the permissible tilt is about 6 to 7 mm, whereas it has already tilted 16 mm, which is quite high. So the tilt is not acceptable. In addition, the permissible difference settlement of the isolated foundation is, we know that if you see in soil mechanics, 1 in 150 is a difference settlement allowed. But so this corresponds to about 6.67 mm for 1 meter footing and 10 mm for 1.5 meter footing respectively. So the observed value of 20 mm, what I observed was much excess again. So both total and difference settlements were not satisfactory, and what we did was that we had to rehabilitate that with some sort of measures using, like, see, thing is that now it is already a constructed structure. So you have to bring it back to the actual condition. So what we suggested was lime slurry injection. So the treatment of the expanse soil area using the lime and fly ash slurry, foundation rehabilitation and drainage measures suggested towards possible improvement of the ground conditions and foundation response. What we did was that since the thing is that first of all they did not understand that the expanse soil has such a, it creates such a havoc. So but then when it has this type of distress, you need to solve this issue. So what we did was that the lime, about 6% lime, and also the fly ash, as I just said, the liquid limit of this expanse soil is about 85 to 90% liquid limit, and then the shrinkage limit is about 10%. We got it tested and all that, and after that using lime about say 6%, what is the liquid limit and what are all the limits and all that we got, we know that the liquid limit will come down and all that, and everything will be all right. And then we also added fly ash. Why? Because the for a it also increases, it is like a mechanical modifier, fly ash is somewhat coarser, and it is also stabilizing, as I just mentioned some time back, that use of fly ash is also very good. So lime plus fly ash in the form of a slurry. Slurry means you mix it at a very high water content and then pump it under the foundations. So if you pump under the already the existing foundation, actually first thing is that we have to rehabilitate the foundation. The thing is foundation rehabilitation is very important. If something is tilting like this, remove the soil from some amount of soil somewhere, see that it comes back to the original condition. You have to there are so many electrical poles in the area, you have seen many, about 40 to 50 poles electrical thing. You have to go to the foundation, measure the actual movement. You have already measured the movement and remove some amount of soil and make it structural adjustment of the foundation itself, because the foundation itself is not very big, actually it can be handled, it is just maybe 1 meter by 1 meter, 2 meter some size. So you have to apply some sort of load or something, and some sort of pressure should be applied, or you remove some soil and then remove the pressure and all that. Make sure that the limits that we got, like whichever it was all exceeding, whichever was I was just mentioning, all these are all exceeding. See that somehow you bring back to the original condition, and then see that these limits are achieved for all the poles, and do that lime treatment, because the problem comes from the actual soil itself, like it should not occur. So first thing is that they should be brought back to the actual conditions in some form by loading or removal of soil and whatever, and in fact the removal of soil to increase to reduce the tilt was done for Leaning Tower of Pisa itself. The Leaning Tower of Pisa, it's had an inclination that makes it very attractive, that is why they do not want that leaning tower of Pisa to be perfect. So, they wanted an acceptable inclination. They in fact they are very successful in that, and same thing we try to we have suggested here that you would remove some amount of soil to see that it comes back to the actual conditions, and it is a structural adjustment by some loading or whatever. Put some sandbags next to the foundation, use some pressing or remove soil and all that, and whatever you confirm it from your measurements, you use your survey to see that it comes back to the actual required levels. Then the foundation treatment was done using the lime flash slurry with the following suggested rules, and it was expected to be satisfactory. So, what I would like to say is that the stabilization methods using lime columns, in fact you should use also some additives if required, but though the essential stress is on lime and lime here, like one can say one can use as a just used flash, one can also use cement also, as I just mentioned, to increase the rate of reactions or the formation of the cementitious materials. So, for example, cement itself is quite expensive, so why do you use cement, and use only the lime and maybe a little bit of cement could be used to increase so if you are able to get a very good strength improvement based on our calculations and observations, it is satisfactory. You do not need a pile foundation. So, essentially these methods could be used for like pavements, particularly lime treatment is a very an excellent method, and also support structures, light structures. The problem with many of the structures is that particularly expansive soils and light structures is a very bad combination, that the expansive soils have swell pressure which could be about 100 kPa or 150 kPa, not less than that, or even it could be you can measure in situ swell pressure also, like you can take an undisturbed sample, or you can do a lot of tests there. So, the swell pressure should be higher. If it is higher than the loading that it is coming, it is a serious problem. This problem occurs in many cases in India, where the canal linings, expansive soil is there everywhere in India, you are trying to put canal linings, and if you have canal linings, what happens, the lining is so thin, like it is just a 150 mm concrete slab or some sort of lining, and it swells, the whole thing is gone. And there are so many areas in many places, particularly in Maharashtra, Karnataka, or even some places in Andhra, where the expansive soils have really made a havoc. In fact, there is some more problems connected with many issues on expansive soils, even in some places in Andhra Pradesh, where say for example, one of the big projects like Polavaram Dam, many of the canals have expansive soil layers that are there. So, one should really understand some of these behavioral aspects properly. You have to measure its expansive nature, in the sense liquid limit, plastic limit. You should do disturbed representative samples as well as disturbed samples as well as field samples, because what happens is that many of the cases, like I was talking about the swell pressure in the lab is different than in the field, because that is very clear. So, if you design the swell pressure for this, say for example, if the swell pressure is 150 in the lab, you may get only a 50 kPa in the field. So, there is a big difference, because in the field the sample sizes are it is a big mass, and then you have a lot of sample fixtures, fractures and many other things. The swell pressure may not be that much compared to what you do in the lab. In the lab you take an undisturbed sample, and then even if it is an undisturbed sample, the possibility is that it could be little higher, because if the sampling itself is you are supposed to represent a big volume of soil. So, one should be very careful in characterizing this expansive soil. As I just mentioned, the other one, very important one, was that you should not use lime treatment when you have a sulphate bearing layer present. So, you should find out the sulphate content, and if it is if it is tolerable within, there is some specifications actually given in particularly the codes are one must refer to the codes by Texas department, where they have somewhat standardized. So, one can see that and then avoid such problems, because you may say that the expansive soil the treatment using lime may not be it's not applicable to all the situations, one should be very careful. And the other thing was that even it's a clay mineral is also very important. So, one should do some more information details on this, and so one can use this treatment and then one can calculate. I just showed you all the calculation methods of calculating total, the bearing capacity, then different settlements, total settlements and all that. One can work out stiffness and all these parameters. These are all the calculation methods, and finally you should measure in the field. And durability tests also, in fact in some cases where I just showed you payment for about 10 to 15 years was alright, it is very good. Like payments do not last for even 6 months, but if a lime treated soil can serve for about 10 years, it is very good. So, what I want to say is that this lime is a very useful technique. Lime addition, particularly using lime, is quite useful. So, I have a couple of references in this, that where we have some from the home page of a particular company. I got some information, and also that it's a research report, and also on the from Texas A&M. So, I am sure that you will have a good understanding of some of these aspects of lime treatment in whether it is in expense soils and soft soils. Thank you.